I'll again see at the end how many students are there. So the problem is this one, incidence of a rare disease. Only 1 in 1,000 adults is afflicted with a rare disease. So out of 1,000, only one actually gets that disease. That's a very rare disease for which a diagnosis test has been developed. Okay, so a diagnosis test is also there that has been developed, but that is not 100% accurate actually. The test is such that when uh, when an individual actually has that disease, a positive result will occur 99%. Means 1%, there is error of 1%. Those who are actually having that disease, but if they are tested only 99% of the time, the result is positive. 1% error is there. Whereas an individual without the disease, a test will show a positive result only 2% of the time. Means out of 100%, those who are not having actually that disease, 2% are getting positive results. Means that 2% is the error actually. If a randomly selected individual is tested, if a randomly selected individual is tested and the result is positive, that is known. This is known that randomly selected individual is positive. Then what is the probability that individual has the disease actually? Result is positive, that is known. Then what is the probability that individual is actually having that disease? There is some error, that test error may be, he may not have that disease. That may be the case. So to use this Bayes theorem, we will use some notations. So we suppose this A1 is an event that is denoting the individual has the disease. Actually, the individual is having that disease, and A2 is an event that individual does not have that disease. Got it? Then I am considering another event that B, and B is saying that the result was test result is actually positive. So positive test result. So these are the events A1, A2, and B. So from this statement of this problem, what are the things we have? You can see that out of 1,000, only one person is having that disease. So the probability of A1, that individual has the disease, is this one. Individual is having that disease, its probability is 0.001. Individual is not having a disease, its probability is 0.99, because having that disease, its probability is 0.001. So probability that he is not having that that disease is actually 1 minus probability of A1. So this is 0.999. Next, what is the probability that it is the test result is positive and it is given that he is actually having, or the individual is actually having that disease. So it is given that A1. A1 means individual has that disease. Then what is the probability that his result is also positive? So this probability is actually 99% of the time when person is actually having that disease, his result is positive. So this probability is going to be 0.99. This probability is 0.99. Similarly, it is given that person is not having that disease, then what is the probability that this test result is positive? So this is the case. And let me plot this diagram again. That will make you more clear. Okay. Let me go back. So you have,
Sir,
yes, yes.
So according to the question, 99% of the time it is showing positive result, right? But then it is written that only 2% of the time is that it will show a positive result without a disease. What does it mean? That
It
disease is
means,
there or not?
suppose a person is not having, suppose I'm testing 100% who are actually not having that disease. I'm testing 100% who are not having that disease, and due to the error in the testing process, that may be due to the testing machine or testing the sample, the way it is taken, that out of those 100 people who are not actually having that disease, the result, 2% of them are having positive result. Means what? The result is showing that you have that actually disease. So that is a kind of error. Means this is the scenario. You can see this one, that it is given that person is A2 means individual does not have that disease. This means individual does not have the disease. This is what given. Then what is the probability that test result is positive? Positive test result. So that is what actually given here, that when individual is not having the disease, a test will show a positive result only 2% of the time. मतलब error जो बस 2% का है. So that's why this probability is 0.02. Got it?
तो सर जो रिजल्ट 99% था और जो 2% एरर आया है उनको ऐड अप करके हमारा 100% होना चाहिए था ना, या फिर वो अलग केसेस हो जाएंगे एकदम?
नो, ये दोनों दो तरह का है एक्चुअली. टेस्टिंग प्रोसेस अगर हम वो एक्चुअली सेम नहीं है. एक्चुअली वो जो है, एक तो हम दोनों दो एंगल से देखा जा रहा है. एक देखा जा रहा है कि अगर हम सारे पॉजिटिव लोगों को अगर हम टेस्ट कर रहे हैं तो 1% का एरर है, और अगर हम सारे नेगेटिव लोगों का टेस्ट कर रहे हैं तो 2% का एरर.
ओके सर, गॉट इट.
That's the testing, actually the problem in the test. The developed test is having that kind of problem. That is already explained in the problem.
Okay, sir.
Okay. So this one is, I am having two leaves. One leaf is, actually it's two branch, not leaf. Actually it's two branch. So one branch is saying that the person has the disease, or person does not has the disease is the second branch. So first branch is probability of A1, means person has the disease. Let me write person or individual. Let me write in simple, has the disease. This side doesn't have the disease. These are the two scenarios actually. So probability of A1 means probability that individual has the disease. This is 0.001, 0.001. Doesn't have the disease, its probability is 0.999. Got it? Now again, if a person has the disease, the test may give two types of result. One is positive, one is negative. Similarly, if a person has does not have the disease, it may again give two results. One is positive, one may be negative. So this is the probability. It is given. It is already given. A1 is already given. That person is having that disease. Then what is the probability that the test result is positive? So this is actually 0. You can see this one, 0.99, and that it is given that the person has the disease and the result is not positive, the error. So error is 0. Probability that it's 0.1 because it's 0.99, so this should be 0.1. And this side, probability that it is given that individual does not have the disease and its result is positive, it's again an error, it's 0.02. And person does not have that disease and the result is negative, not positive. I'm calling it B dash. So this is 0.98. Fine. We call it as tree diagram. This actually gives you a good idea, or I can say a good pictorial representation of your problem. Got it? Then we are actually interested in finding this probability. Probability that it is given that result is positive, means B is given. B is what? B is this positive test result that is given. Then we are interested in finding the probability that individual actually has that disease. So A1 is the event that person or individual has that disease. So A1 is individual has the disease. So this is what we need to calculate probability of A1 given B, and using the Bayes theorem, we have this formula: probability of B given A1 into probability of A1 divided by PB. PB is actually the total probability. So this PB you can write in terms of this PB equal to, you can write PB equal to this one. Actually, it is already written there. PB equal to probability of B given A1 into probability of A1 plus probability of B given A2 into probability of A2. If you have any other event A3, you can add it probability of B given A3 into probability of A3, like that. We have seen for 3 events in the previous example. When I just took one example for law of total probability, then actually I have discussed for 3 events. So here we have 2 events, A1, A2. So it will be having 2 terms. One term is this one, another term is this one. You know the probability of B given A1, you can see either from this one, B given A1, and then probability of A1. You multiply these two, 0.001 into 0.99, so 0.99 to 0.001. Then probability of B given A2, probability of B given A2, it's 0.02, so it's 0.02 into probability of A2, it's 0.999, so 0.999. Then you can calculate it. This will give you the value 0.02097. Then you can use this. You can use this, and this will give you the probability of A1 given B. What is this? B is actually that result is positive, that is already given. Then you are interested in finding the probability that the individual is actually having that disease. So that probability is 0.047, very low. Can you think why we are getting very low probability? Test result is positive and individual has the disease. You can think of this and you can give some concluding line here, concluding remark you can add here. Okay, you can add some concluding remark by understanding why this is and what this mean actually. So any question, let me know.
No, sir.
Sir, PA1, that is probability of having a disease and a positive result will not be equal to probability of having a positive test result and then individual has the disease. Like I mean, PA1-B is not equals to PBA1.
This one.
Yes, sir. Yes, sir. This is not equals to PB-A1.
No. In this one, you simply think that in this one, you know that result is positive. And in this one, you know that the person has the disease. So both are actually just reverse thing. You cannot think that two are same.
Okay, sir.
That is not the scenario. Okay. Okay. How many are present? Let me see. Okay, still 57 are present. That's good. Many come for attendance only. Okay, so I am stopping here. I will discuss few more problems on Bayes theorem because this is one of the important one. So I will discuss some more problem. For today, I am stopping here. Thank you.
So one more thing, how do you pronounce it? Like I said dash, how do you pronounce it?
This one. You may call it A1 given B.
Okay, sir.
Probability of A1 given B.
Thank you, sir.
Oh, thank you. Okay, thank you all of you. You may leave.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Sir,